I'm gonna be relatively quiet because I have my son sitting next to me. So if he's like feeling chatty, I won't disrupt the office hours, but I'll chime in when necessary today.
Yeah. I know he's still a fan of vanilla JavaScript. He's not fully sold on Effect, so we don't want.
It's okay. He's got time.
He's got time. He's young. But yes, I was just mentioning regarding my bathy trip. The one observation I made, and I'm very proud of here, is just how whimsical Britain is, particularly looking at their map. So all of their place names and their food items, really everything. It's sort of it punctuates much of their culture. I don't know why it is. Like in America, we have sandwiches and we have places called Detroit. You know, nothing that makes you smile necessarily. It doesn't make you sad either. It's just like, it's just normal, just stuff. But there they have places called Limpley Stoke and Monkton Combe. And would you like a toasty? And would you like some pudding? Puds. They call them puds. And just every single thing, every noun, every proper noun that entered, that exited anyone's mouth was just whimsical and hilarious. And I don't know why that's happened, because they're sort of a, stiff upper lipped people. Stiff upper lipped people. And yet everything they say is just adorable. It's kind of like Korea in that way, or as far as I understand it, right? They have all the cute animals everywhere. It's similarly cute.
Gabsroar says, let's go for a goof. I haven't heard that one before.
Yeah, I don't know if that's real, but I believe it. Everything is ridiculous. I was trying to get some more silly British, whimsical British place names. I was coming up with a list of it, but just looking at the map was adorable.
Goof is a swim. Wow. Okay, that's
goof
different.
Is a swim. Well, we should go for a goof at Nempnett Thrubwell. Nempnett Thrubwell is a place. I mean, it's not just, I'm realizing it's not just Harry Potter. I thought when I read Harry Potter, everything is giblets and goblets and so. But no, it's just British. It's actually just a very boring novel. And J.K. Rowling gets all the credit for just being British, I guess. I thought it was her whimsy, but no, she's just absorbed it from her homestead. Anyway.
Well, we're very happy to have you back. And
Thank you.
I would like to thank Estranged HD and Gabsroar for the follows. So thank you very much.
Yes.
What are we chatting about today that I'm going to try to chat about, but you'll hear him in the background?
I don't know. Well, let's take a look. Let me see if anyone, we have a Discord, so if anyone has posted any questions on the Effect Office Hours Discord, that would be swell. I can share the link. Copy link into this chat, and who knows if that'll work. Yeah, and I don't know if we get all the messages that are shared in Twitch in the Riverside chat, but maybe. Yeah, I did kind of want to, if we don't get any questions, sort of walk through a little example.
Let's do it while we wait for questions.
On services. Let me grab my little thing here. Where'd it go? Yeah, that'll just take me a moment to open up the right folder. Yeah, I'm working on writing a little on the plane back. I it's a long flight, so I had a few hours to start working on an article on services, which I think is probably my favorite part of Effect, but maybe the most confusing part of Effect. Possibly. So if anyone has any questions on services, I'd like to show off a little example, a little walkthrough here. But we'll see what I'm capable of doing. I've been changing my editor setup so frequently that I'm a little disoriented at all times. Please show. All right. Let's do it. I will share my screen in just 1 minute.
Gabsroar says, maybe give us an intro for the newbies. I'm new to the hood. Welcome to the Effect hood. It's a great hood. Some would say the best hood.
Here, let's go. Share screen. Good. Trying to, bun run source. I'm pretty sure I have a way of, some way with running a task. Task, Shift P task. Open tasks. Nope. Run with bun. Oh, yes, perfect. Run with bun. Run with bun. Tasks. Spawn task. Run with bun. Great. Well, that's not very interesting. Okay. So, can you see my screen? I should probably make this a little larger. Is that reasonable, or is that too tiny? Yes, I use that. I use that again. I was using. I was trying to do NeoVim, but I failed. And these days, I'm mostly. Oh, yep.
I think you may want to. Some folks are telling me that they can't see you, so you may want to click one of the other layout options in Riverside. Just see if
Oh, really?
Maybe there's like one where you can float yourself into a little.
No, that one just gone.
Just see your screen. Yeah.
I see us both on the side.
Oh no, I think it was just actually their window size. So I think we're good.
Oh, okay.
I think we're good.
Okay, cool. Yeah, let me know if you wanted the text any larger, anyone at any point. And we'll talk about. I will now commence rambling about the service pattern, which is what I call it. I don't know if there's a better name for that. Just services. We have a few interrelated terms, and maybe it's worth laying them all out.
I kind of like the constructor pattern for like the whole theory behind why we have services set up with the way they do, and like why dependency injections is set up the way that it is. I mean, you could use a bunch of different terms, but I feel like I lean into this like constructor pattern term quite a bit. I don't know.
Okay.
But I think they all fit, to be honest.
Yeah, we have some kind of pattern. There's some sort of pattern. And what does it exactly mean? And there's some actual data types that are going to be implicated in this pattern. Service is actually not necessarily a data type, mostly layer and Context.Tag, and therefore also context. So this is why it's a little tricky to teach. Because it involves just enough data types and concepts that it sort of just exceeds what one can reasonably hold in working memory to click. Yet there's good reason for it. I mean, some work will be done around sort of consolidating and coming up with better names, which is, I think, an effort that's underway for V4. There's much discussion. We'll see where that all lands. But there's a very interesting pattern of some type, giving it some name, and certain data types are implicated in the execution of that pattern. And so, yeah, I'm going to show off a little example, and we'll hopefully all understand everything that is to be used. Yes, and this is all going to be recorded, and always is. So there's some pattern. What is the pattern? Well, it's a little difficult to describe, but it gives you certain things. Autocomplete is odd. For me, why I like it so much is, I'll actually back up just a couple steps. So Effect is sort of based on this library for Scala named Zio, and that is sort of based on certain libraries from Haskell and patterns from Haskell. So there's a long lineage of effect systems. It might seem odd if, you might think that because Effect has sort of recently sort of shot up in sort of awareness in the TypeScript ecosystem, that it's this very newfangled thing. But no, it's built. It is a long and rich lineage. So there is actually a history here. And there are some patterns that I've been using for many years that I really like. And so when I first fell in love with these patterns was back in Haskell using some library called Polysemi, which was an extensible effect system for Haskell. That doesn't really matter so much. But there was a way of writing code and writing programs that was very nice. And it resolved a whole bunch of anxiety and fear. Anxiety is the barometer I use with which to navigate sort of the terrain of code, and which patterns draw me into them. It's like, which patterns make me feel comfortable and happy? And I realized I tend to be comfortable and happy when things are sort of reliable and maintainable and easily understood. But it's almost easier to figure that out just by sensing how much I'm afraid and anxious. I have a good sense of my anxiety levels at all times. And so this is a nice pattern, the pattern we will get to, because first of all, it's very regular and uniform and self-similar and fractal even. You get a way of composing your programs that is the same thing as all level. It basically makes it a tree structure. Programmers love trees because they're recursive. And when something's recursive, you basically get a lot of behavior falling out of a very simple orthogonal set of primitives. So all you really have to understand is the base case and the recursive case, and then you can build all sorts of patterns out of this. And so this is a property of this pattern we're going to get into, whatever. The effect architecture, app architecture pattern, or whatever we want to call it. And it's basically a way of structuring your programs. And for me, it takes I wish there was a less cheesy term than guesswork, but it takes all the guesswork, the fear, the anxiety, the guesswork out of the basic task of structuring your applications. What folder structure do I have? How should I name these things? How do I expose the functions? And it's very tricky in TypeScript as well, because without Effect, I don't even really know how one would do it. I haven't built many TypeScript applications because I tended to avoid it, and that's why I was writing Haskell and Scala, because it frightened me so. But as far as I understand it, you tend to have a lot of sort of naked modules where you sort of just export some const function at the top level, and it does a real thing. And maybe its implementation, async, whatever, will call fetch and do things in the world. I think this example we're going to look at involves maybe getting sort of a feature flag state. So yeah, get feature flag state or whatever maybe is enabled, and this would be inside of a feature flags.ts or what have you, and this would actually make some call out to actually call launch darkly or something. I don't know. An actual service out there. And get back the Boolean state of that flag name. I'm doing certain things very wrong here, but that's okay. Oh, yes, because it doesn't return anything. Whatever. Return throw new error not implemented. There we go. Not really. Cool. So this whole method of organizing your applications is a bit frightening to me because I don't know how to test it. How would I test this nicely? Well, people tend to use, as far as I understand, some sort of v-test mocking or jest mocking libraries, which is all very horrifying because it's not type safe, and it actually it works via some really perverted mechanism where it hacks the module imports. It does some crazy monkey patching stuff that just isn't type safe whatsoever, and it's kind of low level and doesn't give you very many nice abstractions. Like you have to sort of make your mocks per test. They're very brittle. There's no place where you can define one really nice sort of test fake setup where you sort of define this abstraction that's a test version of some service and you can import it everywhere and sort of have this one nice maintained thing that makes all your tests really beautiful to read. You just do this ad hoc mocking, and that just that's just a practice that makes me feel very, very nervous and very the perspiration begins. So that's one issue that causes me fear that is solved with the effect architecture pattern, is how to test this stuff. And the other one is, in terms of this sort of tree structure of your application. So we have this feature flags, module, service, whatever you want to call it. And you might have some other service as well. I think in this application, it's it's a PR reviewer service or something. I guess the theory behind this application is going to be, I might actually change it to something like a pricing module. And so this might be some function where we want to get a price, and we sort of give it some product, or maybe we even give it like a base price. Maybe that'll be simpler for me to fake out here. And then this is going to return a promise of a number. And then here we can do something. Maybe we'll just, for now, return whatever promise dot, what is it, resolved, or success, what is it called?
It's just
settled?
resolve.
I forget what, is it just resolve is the one that just succeeds?
Yes, sir.
I should know this stuff. And this is sad because get price implicitly has...
Just need an equal sign.
You're right.
You
Many
are
ways of doing
absolutely
things.
right.
You're absolutely right, Maxwell. So yeah, whatever. This is obviously a pretty stupid function right now. Perhaps this would apply some base tax, etc. But it might want to depend on feature flags. We might want to have something where we sort of get, is surge pricing enabled? And then we want to await the importing of, we'll have to import this from this other file. And then this will check to see if surge pricing is enabled. And if is surge pricing, then we'll do base price times 1,000. Otherwise, just base price. And so, yeah, we sort of have this tree structure here where pricing depends on, obviously, this feature flags module. So there's this implicit internal dependency graph that we're forming, and this can get very complicated. This pricing is obviously going to be used at some higher level application module or service or whatever, along with many other random foo service and bar, and maybe this one will also depend on bar, et cetera, et cetera. So you're building this layer graph, but it's implicit, and it's sort of hard coded in this case to being the production implementations. You can't easily swap out the implementations here. With I think what, as far as I understand, is a very common way of structuring sort of Node and Express servers. Of course, with TypeScript, there are no real idioms. There are thousands of ways of doing things. So I'm sure there's many libraries are using Sails or are using Hono or are using something else. Maybe there are some frameworks that you can use that make this a little easier. But I think generally, type safety is not something you're going to get here. Like, nowhere is this expressed at the type level, this graph. And when you go to test get price, it is unclear that it depends on some other function, which will probably actually make a real fetch request. And you sort of have to look at the code and have a deep understanding and hold all of that in your mind, and then make sure you mock out the right things in the right places. And it's all very brittle and hard to update. And why I think this is more important than ever. I mean, it's always been important to me because I like to have these things sort of solved for me by the type system and not have to hold them in my head. I like to free up my mental capacity to sort of reason, to be better able to reason with my full working memory through the harder problems of the code base rather than just sort of some, tracking of what's being used where, which is kind of boring. So being able to offload that onto the type system would be a wonderful thing. And even more so today, because today, in the age of AI and agents, we're offloading ever more code production to these machines that we're running in parallel. And the more that we can constrain them, the less sort of cruft they have to pull into their context window just to understand what's being called where. They can sort of fail early and get feedback early from the type system, just like we humans would, but it can be nicer because then we'll be able to run more of them in parallel. As much as time as it saves an individual person, it's easy to be like, whatever, I'm going so slow anyway, or sort of just not notice the pain, really. We easily become habituated to having to do that. It's just never worth understanding. Like, if we don't understand the types, there is some knowledge curve here that we have to work through, some learning curve. Obviously, that's why you're here. That's why I'm talking through this. So it's easy to make that trade-off and just be like, I'm just going to do what I always do and just deal with this fact and I'll solve this problem some other day. But now that we have all these agents working, that little overhead sort of is multiplied per agent who can work faster than you. So this might be a way of keeping them on the rails, because literally certain structures, certain things they attempt to implement will immediately be swatted down by the type system, or they can just look at the type and understand that certain invariants hold instead of having to read the entire subtree of your application and load into files, load into memory, load into context, all of these files that would otherwise sort of be meaningless and are mostly noise, except that they need to do it to figure out a dependency graph.
You don't have a 200,000 token context window in your mind?
Yeah. No, I have a few tokens, really, on a good day.
Just a few tokens.
Just a few. And maybe this will change in the future. Maybe, the next version of AI in 6 months from now, we'll be able to just understand everything perfectly and we'll always load the full code base. But I imagine there's going to be a pretty sizable intermediate window, sort of a transitory period where being able to rely on the type system, as long as they're still writing code, so long as agents are still writing code instead of just sort of raw binary or their own languages that they sort of develop ad hoc that we can't even read, it will allow them to scale further if they have stronger foundations. So it's sort of another tactic of optimizing their context window and reasoning abilities. I would imagine. They seem to be really good at logic programming, and they always have been, going back to even like GPT-3 Codex. It was always really good at sort of auto-completing the initial Copilot stuff, really complicated type-level Scala functions. So I think it's been always sort of preternaturally able to deal with that kind of logic programming. Anyway, this is what sucks in my mind and gives me anxiety and agita, or whatever they say. And instead, how does Effect solve this? So it will give us a very clear way of structuring our applications, that is these different modules, in a way where the intermodule dependencies become reified at the type level. So it will force us to reckon with these dependencies, and we can sort of swap out like Legos different implementations, both in production and for tests. And it makes testing these things absolutely trivial. So maybe I can just call this, bad get price.
I actually have an example. We can, like, an actual production code example we can look at when we're done.
Perfect.
Wrote for Effect v4.
Amazing. Would this be of a good layer hierarchy example?
Not necessarily layer hierarchy, but more showing how, like, by making dependencies explicit, tests and testing in general becomes clearer, and you can mock out service implement. Like, what I want to show is like how easy it is to mock out like a service implementation that lends itself to testing, for example.
Okay, I'm very excited.
In a situation where it would generally be difficult to do so. So the example I have in mind is like the mock language model I set up in the v4 repo for testing like language model implementations.
All right. Well, that would be perfect. Yeah, it would be good to. We'll start with this very simple example here, but then being able to jump to, once everyone understands the general structure, what it actually looks like in production. Because that little graph that we have on the Effect homepage, where vanilla JavaScript does win in extremely trivial applications in terms of complexity, but then is quickly overtaken by sort of the exponential effect. Maybe it's the other way around. I forget exactly what the y-axis is. But in the simplest example, like this one-page thing, learning new concepts. Why would we want to learn new concepts? I can read this. This is understandable. But once you expand this to 10, 20, 30 files of a real code base, not just a trivial example, it quickly pays for itself. And then if you go even further to some really complicated or very interesting production-grade stuff with retrying and whatever you're doing with Effect AI, swapping out different instances, it really does pay for itself. I mean, you wouldn't even be able to do it with normal JavaScript whilst remaining sane. I'm going to have Claude try to whip up some example in the background for that. But while that's happening, let's keep going here. Are there any questions? Let me swap over to my browser. I've not even peeked. Okay. All right. Hopefully this all makes sense. Please ask any questions as we're going. So, how would we do this? I hope this sort of general structure makes sense to us, where we have like a pricing module. I'll sort of break it down to just the simplest possible fractal structure here of a pricing module that depends on a feature flags module. And hopefully Claude it's taking a really long time to read a file. Why is it taking you a really long time to read a file, Claude?
This is getting very suspicious.
Yeah. It's really just parsing this Talmudically. Okay. So this is
There was a question in the chat while Claude is crunching a little while ago, which was let me scroll up to it. When working with services, do you prefer to declare all dependencies up front in the dependencies array? I guess this individual is talking about Effect.Service, but generally, do you prefer to provide all services up front, or do you let them bubble up to the root of your application and provide them there? Um,
This is not.
I think that we generally encourage local provision of services where possible, because number one, if your layer is static, and what I mean by static is like it's not a layer that's returned from a function. If you have like a referentially equal layer, providing it locally is no different than providing it at the root of your application. And then if you provide it many different times in the same layer graph, it'll all be memoized, so it doesn't really, there's no like performance impact. So local provision of services for the dependencies of a service that you're building is generally better, because then it makes the final like layer composition at the root of your program makes the final layer composition at the root of your program much simpler. But there are situations where that's not possible. For example, like if you have platform dependent layers and you want to expose different versions of your application to run on different platforms, obviously you can't provide those locally, because then your implementation would be tied to that platform. I mean, you could have different layers like for each platform coming from that serve that particular module, but generally speaking, local provision is better than providing it the root, to keep the root layer composition much easier to deal with. So yeah, I hope that answered that question.
Yeah, maybe we could take a look at that when we actually implement this. So it did, I believe, add the bad version. So this is my understanding or my proposal of what maybe a bad vanilla JavaScript, sort of your bog standard TypeScript module application architecture might look like, where we'll have a feature flags file that exports some async function that does the real thing. So this simulates hitting a remote API, I guess. And we actually don't want to hit this because this isn't even a real API, but whatever. It's sort of an example here. And then pricing, which is trying to import from feature flags, relative import. Okay, whatever. Let me have Claude fix this in the background. Not that it matters so much. Okay, would import this other service from another module. It depends on. Oh, it was just JS. That was stupid of me. Okay, and then uses it. So it checks to see. Okay, if premium pricing is enabled, then we'll do this other thing. And if it's discounts code are enabled, okay, we get $5 off. Whatever. So there's some logic that depends on another service, which in the live implementation, which is sort of hard coded here, is going to hit an external API, which makes it very difficult to test this. Because you might want to imagine testing well in various scenarios where premium pricing is enabled or disabled, and same with discount codes. This whole combinatoric explosion of possibilities here. We would like to test as unit tests. But as far as I understand, if you write your programs in this way, you'll have to use some kind of mocking library, which takes a path to a module, like the file path, and you have to mock out the function here. And will this work? Let's actually see if it does indeed work. It might. I would imagine. I trust Claude to do it to work. Okay, so all these paths. So it's mocking this file-based module thing, and it has to list the function name it's overriding and replaces it with this vtest function object thing. Then you import. Actually, you're importing the mocked version because basically this has to all be run by vtest, by vt, so that it can properly reorganize this file and stub it, like the actual import system of JavaScript out, which is crazy. I mean, if it works perfectly and it has really nice UX, okay, fine. But it doesn't. It doesn't have great UX, because if I change this, if I make this poo, nothing happens. Like there's no errors here. No red squigglies have appeared. Of course, if I try to run the test, something awful will happen. So you could say, fine, well, why don't you just run the tests? Okay, maybe. But we're doing something really bad here by mocking something that just isn't relevant, that doesn't make sense with the structure of this module. It's completely untethered to the type system. And there is a chance, depending on the test, that it might still pass. And you would never know this. This is where my heart rate, my blood pressure starts to rise, because this could fail in all sorts of crazy ways, and you have no one helping you out. It's just you have to make sure you got these strings to match up. The file path also needs to match. Like I can have the wrong file path, What if I want to refactor my program and rename feature flags or move it into a different module? Nothing will update this. Imagine I just did that in the background. This would look the same. Just as if I sort of, it used to be in just example, and then I made it pricing example. Well, we won't find out until we run the test, and it happens to, luckily in our case, fail. But that, once again, that's not guaranteed to happen, depending on what's going on.
I'll also add that, like, for LLMs that integrate with the LSP, like having this information available at like statically in the LSP is quite nice for providing that back pressure to the LLM before it like performs your next generation or whatever. Like Kit mentioned, like, because like none of this is type safe, it's kind of stinky for the LLM, and the LLM actually has to like run through your test suite, see the error, try to figure out what the problem is, go search all your code paths. Like, there's a lot more work that has to be done by the LLM as opposed to getting a static like LSP compilation error and like it's seeing, oh, there's an actual problem, let me fix this before we run the test or whatever.
Exactly. Type systems are meant to be, some people complain about type checking time. TypeScript's pretty fast. The new TSGO implementation is even faster. It's meant to be this really lightweight verification of invariance of your program and to be useful. And so open code hooks into LLMs. I think some other ones do as well. I think there's some experimental setting to get Claude Code to do it. It's definitely going to be used more in the future because it's super valuable. LLMs do great. Agents do great with feedback loops. It's the sort of the lowest cost, fastest, constant running feedback loop that will just keep your program on track. I think there are going to be more types in the future. Why not allow your programs to sort of express the invariants that they require and sort of connect these and resolve these across your entire code base. Increasingly complicated, increasingly Ralph-spewed, Ralphed up code bases. This will do much better to keep them in line, at least, and allow them to iterate more quickly, if nothing else, and more efficiently. So yeah, I hope I've expressed this is kind of shitty and a little weird. Because nothing is tethered. You just have to make sure you've gotten everything correct, and then you sort of can't change anything. And that's probably one of my favorite reasons for type systems is that, like, over time you build better understandings, or just every time I say you, replace it with you and your agent friends. Over time you develop a better understanding of the domain that you're operating in. And it would be great if you can update your code to express your current best understanding. Types can be self-documenting, and they let you refactor without fear. Otherwise, I don't know. In the past, you write a 1,000 file, a 10,000 line even JavaScript code base, let alone 100,000 line JavaScript code base without types or with insufficient types. It's very frightening to refactor because you're going to miss things like this everywhere, and it's going to mean more errors in the future. So you basically can't refactor, and then your code base sort of gets brittle. Maybe in the future things will change because you just keep rewriting the whole code base for free every 2 seconds, but we're not quite in that world yet.
So what if this is the idea now? We'll take this and see what this would look like with like an Effect.Service based version.
Yes. So now I think I've done enough preambling. It's more time has elapsed than I'd realized. So let's do that, and let's do it quickly. So I hope that the pain and the motivation is there, and now we can actually implement this. So how do we think about this? Well. And I'll sort of just walk through it, and then we can explain after I walk through it the actual details of how things work, if that's interesting. But let's just do it like, how would we rewrite this in Effect? So I like to think of it from in terms of what I'm guessing I'm calling these services. So we have this pricing service, so a name and a set of methods. So get price, which is going to take a base price or whatever. How did it do it in this other one? A base price and a quantity, fine. A base price and a quantity, and return the actual price based on various factors. So that's what that service is shaped like. And of course, in Effect, these were going to be effects instead of promises. So that's that one service. And then, of course, we have a feature flag service, which is enabled, and it takes a flag, which we can represent as a string, or I like to also similarly use branded types and schema types. So base price and quantity. These could even be different types if we wanted to. I guess for now, I'll just keep them numbers. Maybe I will make one for flag to distinguish it just from a string. And this is going to get us back an effect of a Boolean. Yes, and so these are sort of the interfaces. So it's nice to represent these types as interfaces, and the effectful version of an interface is a Context.Tag at this moment. So if you see this word, think effectful interface. This defines what I'm referring to as a service, which is basically an effectful interface. So a few different words for the same thing. We're going to work on that. So let's start with pricing. We can start from anywhere, which is nice because it's all the same. So I'm going to say class pricing extends context.tag pricing. Oh, there we go. That was nice. It did the LSP autocomplete. I need to import some stuff. Context.
Yeah, shameless plug for the Effect LSP, because there is a little bit of boilerplate when setting some of this up, and the LSP just does it all for you. And
Yes.
Setting up the LSP is literally a one-line config in your TS config, so it's pretty great.
I'm going to make this tag shorter even though it's best practice to have the full path to the module, but just to make it a little cleaner for a simple example. Oh, and then I almost had the autocomplete. How do I trigger it? There we go. Okay, so there is some syntactic overgrowth here, admittedly. That's sort of just the price we have to pay to get TypeScript to align with us. There are some limitations of TypeScript. It's a very powerful type system, but it does not have a metaprogramming. It has certain innate limitations that we have to work around. To get all of the powers that we need to sort of use this structuring here, which boilerplate, I would argue, has never been cheaper, has never been more low cost, because you probably aren't typing too many lines of code by hand anymore, unfortunately, however painful it might be. I used to love and take great pride in my words per minute and my ability is with Vim, but that has slightly atrophied, I'm ashamed to say. Nonetheless, you will eventually learn how to pattern match out of this what is important, which is basically the name, which is pricing, and the interface, which is here. So we have the name and the interface. And you'll sort of just eventually just see that. This is a service called pricing of this shape here. Okay, so that's one bit. And now we can just go to the feature flag implementation as well. So feature flag.
While Kid is typing this, I want to point out how repetitive this pattern is, which is, again, really nice for LLMs, but it's also nice for humans. Once you've seen it once, it's pretty easy to grok what's going on here. And this, every single service in your application is defined the exact same way, which is really nice.
Yeah, that's kind of what I got, but I was trying to gesture towards with this regular, uniform, self-similar fractal word salad business down here. It's just you don't have to worry about it. You don't have to think about how am I going to organize my application. Well, for anything that is service-shaped, that is an interface that you're going to want to share unmodified throughout basically your entire application or a significant subtree of your application, model it as a service, and this will bring you great pleasure and great joy. So yes, there's a bit of extra boilerplate we need, but this is what's going to enable all of the other nice features we're going to take a look at in just a moment. So one of these features is now we can implement one, and we can start with. It's interesting. We can actually start with the higher level service. Note that pricing is going to depend on feature flag if we looked at our previous example, the bad versions. So we can do that here. And we can make what is called a layer, which is, Maxwell was saying, sort of the word constructor pattern. Think of, so if a context.tag is an effectful interface, then this is an effectful constructor for a service. So this describes the interface of a service. This describes how do we make a service. And you can have multiple constructors that do multiple things. We can make multiple implementations of services. So it's a constructor / implementation for a service. And in the case of pricing, because this is not a Leaf service, we're actually going to only have one implementation of this, probably. You can actually make multiple at any level, but you will tend to realize for various reasons that these sort of intermediate services tend to just have one implementation. And that's because the variance of their behavior is going to be determined by which implementations of their dependencies we provide.
And answer
So
a quick question, Kit,
yeah.
really quick in the chat. Well, there was a question I think that was going to come up from the way you were declaring this layer, but the question was why put static props on the tag versus declaring the layer at the root of the file? Jay, either one of those is fine. I think that the reason why in an application code, putting these as static props is kind of nice, is that you're usually not worried about tree shaking your live layers with services in your application, because this code is all going to end up getting used anyways. And so you only have a single import. You can just import pricing and use it both as the tag. You can call pricing.layer as opposed to having to import the full module and then call pricing.pricing, et cetera, et cetera. In library code, having layer at the root is better for tree shaking. Because static props can't really be tree shaked.
Yeah, I mean, and so, like so many decisions, it's sort of arbitrary. Like, yes, in our case, I could define it here on the class as a static, or I can just say const layer, or probably would want to say const pricing layer, just so everything looks prettier for our example. And I could say pricing.layer. I'm doing it like this, but it's kind of arbitrary.
I mean, it's all bike shedding, and like most like you can do whatever you feel is best. But like if you want to talk like technical reasons, from a tree shaking perspective, a static prop is worse than having it at the root of your application. But again, this is kind of just like bike shedding, and it's up to you how you want to do this piece. The layer can be defined wherever, as long as it's available.
Yes. So, and also in a real application, I might even have like a services folder, source services, and then a folder per service, especially if I have different implementations. So there might be like the actual service, or maybe I'd call it feature flag, or I don't know what pattern. It's always kebab case, whatever you want to do. I don't know. So this might be the actual service definition, which is literally this thing and any types. Like if we did have a flag type, that might go in here. And then each implementation might have its own file, because they might be kind of complicated, and we might not want in here to have like the full implementation of launch darkly and switchly and whatever the heck all the other feature flag services are. If those were separate implementations, it might make sense to have those in separate files. So this is kind of arbitrary. Exactly. It's going to depend on your application, but for now, I'm working on the constraints of trying to pack it into one file, so it's sort of understandable and easily parsable.
One last question before we continue with the implementation. Mm-hmm. The question was, why no Effect.Service? Is it because it's still experimental? No, the reason why there's no Effect.Service is because we're sort of disadvising that pattern moving into Effect 4.0 because there's too, quote unquote, like too much magic in quotes going on with Effect.Service. We actually haven't even implemented Effect.Service in 4.0. We have like other patterns that are working nicer. And being a more declarative is better for LLMs than they seem to perform worse in our experience with Effect.Service than just letting it have access to all of this information, this rich context with Context.Tag. Such a subjective metric. Daniello, I disagree. We've done a lot of experimentation with that. And the other problems with Effect.Service are there's limitations on what you can actually do with Effect.Service versus Context.Tag. For example, in the current implementation, it's very difficult to have the constructor be a function that accepts arguments in a correct way. And again, this is something we're evaluating removal, like not having in 4.0. We have other patterns in 4.0 for constructing layers and making it a little bit easier versus having Effect.Service, which does a lot under the hood for you and abstracts quite a bit away.
Yeah. I mean, we want to make it good no matter what. I think for me, pedagogically speaking, well, there's even just doing what I'm doing here with Effect.Service, it's this other way of doing things. You couldn't just have a definition like this without an interface. You're sort of forced to have an implementation. And so this kind of type-driven design is not available to you. Also, this is how it works under the hood anyway. It's sort of Effect.Service is a layer atop of this. And therefore, it's even more difficult to teach because now you have two ways of doing something, and you kind of still have to understand this way of doing something. And so, yeah, I feel like this is kind of a clear way it's more revelatory of the actual underlying ideas. That's not to be said that like maybe there will be some higher thing exposed, or you can always implement your own higher level way on top of this. But yeah, we'll see what happens in the beta. But I think this is a cool idea. So back to the example. So we have these two ideas. We have the effectful interface, the contract, which is a context.tag, and then we have a layer, which is a particular implementation of which we may have many. And the interesting thing about this is that, well, first, I'll sort of describe the structure here. We define the layer. So we're using a layer constructor, most commonly layer.effect. And this then takes the tag, because this is sort of, as we can talk about later on or in another session, this is sort of like a key into a runtime map of implementations, sort of an implementation detail, obviously, if I use the word implementation there. So you don't have to worry about this now. You can just say, okay, this is the way these things are written, but it is a necessary part of the boilerplate here. And then we can actually implement it. And because this implementation is going to depend on other services, primarily feature flag, we would, at the top of this effect.gen, yield any transitive dependencies we care about. So in this case, I will say const flags equals yield star feature flag. Maybe I'll call it feature flags, actually, now that I think about it. Feature flags, feature flags, feature flags. And so now this gives us a handle on the feature flags interface. And if you could see there, it's the structure of feature flags. And then we can use this in our implementation. So when I go const get price, this can be its own implementation. And let me actually go to the other pricing module and just copy this over. We'll just keep the same, whatever example it came up with. Oh, copying. I failed to copy. There we go. And it's a little crazy right now. Let's see what it did. Ding. Okay, I think it's just sad because of a couple of reasons. Const get price. I didn't wrap this in parens. And this needs to be, I think, effect.fn function star. I'm actually going to ask Claude just to clean this up. But we can basically, instead of calling await, we'll say yield star, and we can say flags.isEnabled, etc. And this should work basically the same. Can you please clean this up? Main.ts. Specifically the layer definition. I've messed up all my braces. And then we need to return the implementation. We'll see once the squiggles go away that everything will become much cleaner. And I can properly add my comments. There we go. Ah, beautiful. All right, sweet. So yeah, we can return directly the get price function from here. This is all good. But we can also, can you please extract get price into its own const, and then we can just use structuring or property shorthand assignment. We'll also use effect.fn to define get price. Thank you. Thank you, robot. It's going to show exactly how I would do this in the real world. So yes, now it has defined the method and then returned the service implementation. So you can have all your public methods listed here. Great. And this is sort of the final structure. If you use effect.get.fn, we also get tracing for free. A trace span will be added to this thing, which is kind of nice. If we put the name here, we don't necessarily have to do that, but I tend to do that actually. So yes, I will add an ugly comment here. So this is now on a second line. Okay, so this is very similar to this implementation, except in this case, is feature enabled is sort of implicitly just imported. It's not implicitly imported, it is explicitly imported, but nonetheless, the dependency in this other module is not evident in the type level. We're just pulling in an implementation from this other file, which is not varied. It's a concrete implementation, sort of referencing this global constant is feature enabled that does hit the actual underlying API if it were to exist. In this case, we have this layer where we, at the beginning of it, define any dependencies, grab any dependencies. We can also do any other sort of effects here, acquire resources that will be shut down later. Then we define our public API. We could also have sort of internal helpers defined up here very nicely, once again in terms of our transitive dependencies. And then we finally return that service implementation, our particular implementation at the bottom. And what's very cool is if we look at the type of this, it is a layer that returns a pricing. The first argument is this pricing service. And the third argument is what it depends on. It's transitive dependencies. This tree structure, this transitive dependency is evident at the type level. It's captured at the type level. And it's going to force us to, how do I add the type annotation there? It's going to force us to reckon with this. If we want to use this implementation of pricing, if we select this implementation of pricing, we will have to provide a feature flags implementation to use in our program. And we'll take a look at that in just a minute. Now, we can do the same thing for feature flags.
Really quick, yep. If we look at the layer declaration here, we mentioned that this is like a constructor for the service. For those of you who are familiar with like JavaScript like patterns and things like that, the effect that we're providing to layer.effect here to implement the pricing service should look very similar to a closure, like a JavaScript, like a closure over the services that the transitive dependencies basically. So flags here is within the effect closure. We're pulling it in. We're closing it over the transitive dependencies, which lifts those dependencies into the layer. And then the methods that we define are able to access information from the closure, which we then return out of the actual service. So this should look, for those who have like keen eyes, should look very similar to like a standard closure, which if you squint really hard, a standard JavaScript closure.
Yes, it's very important that it's sort of it is a pattern that we generally would never have as a rule of thumb in the actual interface methods. We're never going to have any. We're never going to make use of that third type parameter in effect here. These sort of transitive dependencies are always going to be the responsibility of the layers. This is where we decide our implementation and sort of build our internal dependency graph. But to complete the picture. So this all type checks, which is very interesting. But if we ever want to actually use this, well, we'll need to have a feature flags layer as well. But it's nice that you can sort of just use this type-driven design. We can mess around with our feature flags and say, trying to implement this in terms of this flags structure doesn't make a lot of sense. I want to change is enabled to something else. I want to add a toggled method, whatever. We can play around with this interface, get type checking, and not have to commit to an actual implementation just yet. And this would be a really good thing to use with LLMs, of course, because once you have an interface, it's pretty dang good at implementing the actual body of it. For instance, can you make a layer on feature flags called in-memory layer that will accept sort of a var args of strings, the flags to be enabled, and then return an implementation for that, sort of an in-memory implementation. So this is going to be a fake implementation of feature flags that we can use in our tests, which should be pretty useful. And so that's exactly what I was expecting. It has a type to work off of. Obviously, it's pretty clear what it needs to do. So this implementation does happen to take some arguments before it creates the layer. There are other ways of doing this, but in this case, for tests, this is very simple. So we could have had this be some feature flag config service that was depended upon, but for the way we're going to be using this, this is actually going to be really, really nice and easy. Okay, cool. So now, do we have a main? Where is main? Do we even have a main in here? I do. Great. So now we can just quickly run, before we make a test, some version of this application. So I will say effect.gen, and function star, perfect. Okay. And I will get pricing by yielding pricing. So this is now our pricing service, and we have a get price function. And I can call, $20, $10, $20, whatever, price. And I will call effect.log, final price, sure, yielding that. So the type of this effect now is going to be an effect that doesn't return anything, and that requires a pricing, because we yielded pricing. We sort of, the magic of yielding a tag is that it does this, it's a sort of this two-part move, which is that, one, we sort of get to pluck out of thin air an implementation of a service, and for that to work, Because like, how can we just get an implementation of pricing? It's not going to generate it on the fly. Maybe in the future, some LLM can sort of have just-in-time implementation generation, which would be interesting, but and dangerous and non-deterministic. But the other half of this is that it adds a type level dependency to the outer effect, and it propagates. So now main requires a pricing. If we used this in some other effect, that pricing would propagate, and we would have to, before we can actually run this, you see that we're unable to run this now because pricing is not assignable to type never. Run promise can only run something that has never as its dependencies, which means in that position that it has no dependencies, is what never means. So before we can run this, we will have to provide an implementation of pricing. So I will call provided here. I don't need to break this up in such a way, but just to get an idea. I will call effect.provide, and then we pass in the layer. And so we have pricing.layer. Now, if we look at the type here, we'll see that it has the type of feature flags. We still cannot run it, and that's because this particular implementation of pricing needs feature flags. Can you make a very simple pricing layer called static simple layer that simply returns the base price times the quantity? So this could be interesting as well, just so I can quickly show off the difference and why you might want to have multiple layers and where this becomes very useful. So here's a very simple layer, calling layer.succeed this time because we don't need to make use of effects. Did the same thing down here. We don't need to yield anything else or run any effects in the construction of our implementation. We can just return the implementation directly. And now, instead of calling pricing.layer, I can call simple, and I have to run provided, and now it compiles. There is no dependency. And so let me run this program if I can figure out. I need to come up with a good shortcut for this. But there it is. Final price is $200. 20 times 10. Perfect. So we can run it. If I do now, so now how do we do the layer one? How do we provide our full dependency graph? Well, in this case, it might be nice to sort of have an app layer, which will be pricing.layer. And sort of the goal would be to have this be a layer that exports a pricing but doesn't have a feature flags. So we call layer.provide, and we provide its dependency, which in this case is feature flags.inMemory, and we can just give it for now an empty list as sort of the first argument. We can try that first, and this should basically behave just like the other version. So we should still get 200 because all the feature flags are disabled. So let me run this again, and yes, it's 200. And then I actually forget what the feature flags are. We can make that type safe as well. Is it even, it's not surge pricing at this point, is it? It's premium pricing. So we get a 10% bulk discount if the quantity is greater than 10 or equal to 10, which is what we have. So we should see that when premium pricing is enabled, this drops from 200 to 180. And it does. So we're here allowed to sort of mix and match and play with the layers that sort of propagate through our program. And it's really beautiful because this is sort of like a high level, this describes the high level semantics of our program at this level of abstraction. It's a very simple program right now, but it doesn't worry about implementations. It worries about sort of at the semantic layer of pricing. We get a price for this amount and we log it. We don't have to worry about all these other details. Those details are sort of encapsulated at the right level of abstraction where they belong, co-located with its implementation. So to define pricing, we get feature flags, and then we shift our logic around depending on these feature flags. We don't have to worry about, obviously, the feature flags, the details of feature flags implementation. This can be swapped out to be any number of implementations hitting launch darkly or whatever, or not. Okay, now that we have this, let's create a new effect vtest file to test our new effectful services, much like the other whatever tests you made for the shitty version. We'll see what that looks like, and then we can iterate on it. This is very useful for fast forwarding when we're getting near the end. Let me see. Were there any questions? Oh yes, that's the default stuff. Yeah, I'll get to that in just a moment. Actually, Yes, if you're curious about how, going back to our previous tangent about Effect.Service, we have to export these things. Great. Pricing effect test. Okay, great. It would be great if you extracted a helper function called test layer that just took the var args directly, so we can clean up the calls a little bit. Great. So here we're using effect vtest, which is a pretty thin wrapper around vtest that just lets you return effects directly without having to first run them. So you could basically re-implement most of it yourself if you wanted to, but it's a nice little abstraction. Let me run this file real quick and ensure that it works. So all the tests passed, so that's nice. What are the tests? Not sure yet, but we'll take a look. So calculates the basic price with no feature. So we get pricing, we yoink it out of the environment, then we call get price, we get the result, and we expect that to be 50. That makes sense. And then we could test these different feature flags simply by providing different layers. This is what's going to sort of alter our logic here. So with premium pricing, we expect 10 items to get a 10% discount be 90. With discount codes enabled, there's some other special logic. Okay, you get, for orders over 100, you get $5 off. Great. And then the combination of both. There's some special logic here, which is confirmed by our test. And what's beautiful about this, compared to our other test, pricing.test, is that, well, first of all, this just reads so horrifically ugly to me. But, and sort of, it's very ad hoc. You need to sort of come up with a particular implementation each time for feature flags. But here we were able to export this sort of first-class implementation of feature flags, which, albeit, is very simple. But we can make a nice test version. And this is even nicer. Say we had a storage service or something. We can make an in-memory implementation of that storage service that we could easily mock, and you can call set and update or whatever, and it would behave basically identically to whatever a Redis implementation or a Postgres implementation, as long as you're not testing sort of very specific aspects of transactions or something like this. So you can make these sort of really refined, curated test implementations that you could then use in all of your tests, and they become very, very clear and very, very readable. And it's pretty damn nice. And if you forget to provide it, well, you can't. Like if I delete this whole effect.provide thing, well, it knows that we need a pricing implementation. You haven't told us what pricing we want to use to test here. And so we would call, pricing.layer. And of course, now this needs feature flags. So we would have to provide to this pricing feature flags. And that's exactly then what we did with this little helper that first provides pricing and then pipes into it the in-memory feature flags layer, allowing us to easily customize per test which feature flags we're testing. And that's damn good. I don't know, that just makes me feel really clean. So basically, each of these is going to be able to get broken up into its own file. Its implementation is co-located with its interface. And everything is just very beautifully abstracted. I don't know. I feel clean. I feel renewed. This made me feel scared and nervous and sweaty, and now this one makes me feel very, very happy and satisfied. Are there any questions? I guess that's kind of the preview.
I can show how this is used in like our actual code base, like this type of pattern. Can I just do one last thing? Because you can do whatever you'd like, of course. This because somebody mentioned the layer thing. The Effect.Service thing. I forget where that went. But one of the benefits of Effect.Service, and one of the, in a real application, a pattern that's really nice to employ, is once you do have a bunch of services, and they have a fairly complicated, like pretty deep tree, right? This goes on for a while. You have a bunch of, they wouldn't all be called feature flags, but you get the idea. A, B, C, D. Well, then you might imagine that at the top of your application, yes, you have to construct this layer graph, and maybe that's a little complicated. Maybe you don't want to do that. If you always want to provide a particular implementation, like there's probably never a case where this layer isn't going to take, in production at least, isn't going to take the live version of the feature flags or whatever. We don't really have a live version right now, but if we had
sort of a default implementation of this that we always wanted to use. Let me actually just make sort of a one called default. Maybe I'll just call it empty, and it'll just be it'll just succeed with false. So like they're all disabled. So we have the static empty layer. And let's say for whatever reason, we always wanted to provide that for the most part in production. And this service was depended upon by 10 other services, and they had dependencies, or they had parents who depended upon them. It would be annoying perhaps to continuously reinscribe pricing.layer, pricing.layer, pricing.layer. Well, what you could do is make a static default here, which is simply pricing.layer, and then we can call pipe, and then we can call layer.provide feature flags.empty or feature flags.default. Why is this sad? Empty is used before initialization. Oh, maybe that's true. I got to move this up. If these were enough different files, this wouldn't really matter. Cool. So now we have an implementation of pricing that does not need to specify the feature flags. And therefore, we can easily use this in our app layer here and just say pricing.default. And if every service in your application, or most of them, have default implementations, and if those default implementations recursively, fractally provide the default implementations of all of their dependencies going down to the leaf nodes, then basically whatever your top level service is, maybe you make an app service, you just have to say app.default, and that would work in production. And you still have this other layer that it's based on that doesn't define its dependencies that you can use in tests where you probably do want to swap in various other implementations. So that's one of the benefits that Effect.Service gives you for free. It like lets you predefine an array of its default dependencies, and you get this free default layer if you do that. But it's not that hard to just do it yourself and to establish that as a pattern if you find that to be useful. That Effect.Service pattern is really just syntactic sugar. Okay. I think that's it. So yeah, do you want to show off something fancier?
Yeah, I just want to answer. Babenzer had a question. This may be out of scope for the stream, but do you still use layer if you need an implementation that is based on something dynamic, like an endpoint that will use feature flags kit is for the saying in this example. One strategy you could use for that, Babenzer, is you could have an effect that queries said endpoint and returns the layer that you want. So you would have an effect that returns a layer. And then there's a combinator in the layer module called layer.unwrap, which takes an effect of a layer of A and returns a layer of A. So it basically unwraps a layer from an effect. So you basically can do like effectful logic to construct your layer and then unwrap that layer into the graph.
Yeah. Maybe I could even just show that off really quick. So we have,
do that.
You know, so we have simple layer, and we might have like free that always returns 0. Everything's free. 5-finger discount. And then we might have a layer that's kind of whatever called dynamic equals layer.effect of pricing. And this would need to say effect.gen, function star, blah, 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 blah. I need to get some shortcuts. And here we can say yield star config dot string pricing strategy, const strategy. And if, strategy, I guess it shouldn't be effect.gen in this case, but I'll do this in a moment. If strategy equals free, then we'll return pricing.free, which is a layer. Else if whatever, this is otherwise we'll return pricing.simple. And then of course, these are layers. So what is it? Effect, unwrap effect, right?
Yeah, you would just do a layer.unwrap effect and remove the tag, because the tag is already embedded in the layers you're returning.
It's in a layer, of course. So it's just the effect here. Perfect. What's so sad about this?
I think the config module just needs to import. But you can see, like, with this pattern, how, like, this is a simple version of, like, reading a config to build a layer, but, like, you can use this pattern to do effectful logic to construct your layers. So, we use this pattern quite a bit to do exactly what Kit is doing, read configs. But you could query an endpoint, you could do whatever. But again, like, these layers, though they're built once, they do need to be built, and they will be built the second that you call effect.provide and you provide your layer graph. And because of that, all of the layers will be constructed and made available to your application. All of those services will be made available to your application. So if you have a layer that's very expensive to construct, it will only be constructed one time, which is nice. So if you do have like something that's expensive to construct, doing it at the root of your application while it's booting up is nice and generally desirable. But that is something to keep in mind for like testing. If you have expense, there was a question in chat about like, should I just provide my full like layer bundle to my tests? Yes, you can do that, but you should just be aware of like if you have expensive layers to construct, that they will all be constructed when you provide them.
Yep. Cool. Well, I think then that's all here. Did you want to show some other stuff in the
let me take over for really quick, and I'll just show.
Do you steal it from me, or do I need to stop? Okay, it worked. Cool.
Did that work?
Yep.
Let me make this bigger, and let me get rid of all of this noise that GitHub thinks is useful. Is this big enough, or should I make it maybe a tiny bit bigger? So in the AI module, this is in Effect v4, but I want to kind of show an example, like a concrete example of what Kit was talking about, where like you have a complex service, and that service may be like expose particular methods, but you want to be able to test like behavior that depends on that service. So one of the use cases that I had in mind as Kit was talking that I could show is like testing the AI language model from Effect. And I actually built like a little utility in V4, may or may not end up making this like available. But basically, it is a with language model combinator that allows me to pass in like stuff that I want the generate text method to return, or like mocks that I like want the stream text method to return. There's basically just a bunch of overloads here to make it easier for me to write tests. And then in here, you'll see I'm just the effect that I receive. So if we scroll back up here, where are we? Here. This is the data last variant, I think, or data first variant. We get an effect and we take some options. I know the overloads are a bit noisy here, but you can kind of get the idea. We have an effect that we get. We have some options, and the goal is to return an effect that now has the language model provided. So we exclude the language model from the requirements of the effect that came in here. And in the implementation, all I do is I provide to this effect a language model implementation that's totally fake, that just takes the mock like stuff that I want to return and returns it. So this way I can test the behavior of like invoking an LLM, having it return some data, and then making sure our SDK performs the way that it's supposed to. Sorry, my son's getting tired. So concretely what this looks like is in a test, for example, if I want to test that, for example, when we're streaming, that tool calls are emitted before executing tool handlers here. Or maybe I can find like a simpler example. Oh, there is no simpler example in this branch. On this branch, I can have better ones. So in here, let me find a simple one. Tool approvals. All right, fine. We'll just look at the simple one. In here, I've got an example of using the language model service and calling stream text, which is like an actual method on the service. But then, and I do stuff with that. I take parts and I do stuff with it. I do like test logic to see what parts I'm getting back. But the nice thing is, by having that fake implementation, okay, buddy, by having that fake implementation, I can basically say, this is what you should return. And that allows me to test the behavior of the actual like language model service and make sure that our SDK is doing transformations and things like that the way it's supposed to. In this case, it's nice because I can say, this is the tool call that the LLM is going to return. And I've got a mock toolkit somewhere that I'm building here. Where is it? My toolkit. my toolkit is up here. So I can actually test like the code that I've written to control how tools and toolkits interact by returning fake data from like an LLM. So like being able to selectively override services and testing is super useful for stuff like this, and can make testing really complex interactions like kind of nice and easy and actually enjoyable. Like I've got examples here. I'm adding support for tool approval to the SDK. And I can like easily test that using this like mock LLM thing. And there's actually also examples in here. I'm working on adding the Open AI provider integration. There's examples of like mocking an HTTP client to return certain things. So, anyways, like being able to override these services and testing can be extremely useful for avoiding having to do what Kit showed and like declare mocks for an entire module that are totally not type safe. Like everything in these files is type safe. I know that like when I call OpenAI clients, I need to provide an HTTP client because this layer here, this constructor is dependent on an HTTP client. So I can just give it my fake one, right? It's kind of it's very nice to be able to do this stuff, and so yeah. Anyway.
Amazing. Cool. Well, that was quite the whirlwind. I hope that was useful as an introduction to services. I'm going to publish something about this pretty soon, I think, and also do something on Effect.Institute. So hopefully I'll hit you from all angles with...
One more question, just because Philip's asked this a few times and I don't want to ignore his question. If I use command.make in a service method, command executor becomes a dependency. What's the cleanest way to provide that? So I think, Kit, if you want to share your screen again. Okay, buddy. Yes. I think the easiest way to do this, Philip, is to yield the command executor. One way is to yield the command executor itself in the layer, in the constructor closure. So maybe, Kit, you can like show one of these effect constructors, maybe like the one up above with get price here. We could like yield the command executor here, for example, that we want to use, and then we can provide it to the individual methods. That's one way. Which will erase the requirement on command executor from the service methods. Another way that can be less annoying, because in this way, if you had multiple services that your service methods depend on, it can get quite verbose. Another way to do it is to yield the context and then say what services should be available in the context. So you would do like yield effect.context and then command executor or all the other services you need. That would lift those requirements into the layer. And you would basically get a context object that you could then provide to the individual service methods. So like if you have a single service that you need, this is fine. But if you have many, sometimes yielding the context and saying which services you need in there can be less verbose, annoying, whatever you want to call it. But it lifts the requirements into the layer instead of having those requirements leak into the service methods. So maybe like in here you can show like get price inside there. You could call command.make inside get price and just make like a fake yield command.make and make a fake command. I don't know, echo something. Sorry, you gotta what's it called? Pipe it to. I forget if there's I think it's command.run or command.text or command.string. There's like a combinator that'll actually run the command. You could pipe it to. Because right now it's not, yeah. And I'm not sure if that module got imported. I can't remember the exact things that you have to call to get this to work, but you get the idea. And also, Kit, you're muted, just so you know.
Thank you. Yes. Yeah, I'm not entirely sure what to show off here, but yes, you would.
I think you get the idea here, right? Like you run your command in the method, and you can provide the executor if it's needed, or you can yield the context that specifies you want a command executor in it. So if you want to show an example of that, Kit, up above, instead of dealing with the command type errors, up above where we yield command executor, can you also underneath that yield?
I think it is possible to get something like this. Anyway, whatever. What would you like?
You can yield effect.context and just put the command executor generic in there. Yield effect.context. And then in the generic to effect.context, just open up a generic and put command executor in there. Command executor. And then open close parentheses. It's just a thunk. Well, it's not really a thunk, but and this will pull the full effect context in, and it basically does the same thing as yielding the individual service, except now you have the full context. So if you have multiple services that your methods require, this can be like a slightly less verbose way to deal with that. So either one of these is fine, and then you would just take these things and provide it to the service method to erase that dependency, if that makes sense.
Cool. Unfortunately, yeah, you've got to run this. Don't exactly know how to do that. Command dot. Where does it start?
Try exit code.
Exit code. Cool. Yeah, and so now this would depend on command executor. Now we can pipe in effect.provide provide what exactly?
You can just provide directly a context object.
Okay. Cool.
And if you do this inside the service method now, the service method will be able to run this command without having to depend on the command executor.
Yeah, I'm getting all these silly linting errors about unused parameters, but yes, it is going to work now. So we could have provided this, or we could have gotten the service and then provided a service of the executor.
Yeah, the annoying thing with the provide service variant is you have to specify the tag and the service that you just extracted.
I see. So yeah,
that's why the context version is a little bit terser.
Okay. Yeah. True. Amazing. Okay. Well, yes, there's all sorts of fancier extensions of this that we can get into, but I think just like 90% of the time, what I showed off originally is what you're mostly going to be doing, and just express your whole application in that way. It works very nicely. Shall we call it a day?
Cheers, folks. I got to go feed this kid.
Bye, guys.